Okay, so we're gonna start the lemon battery project, or lab, or whatever. So I'm gonna clean off the pennies right now. Make sure they're nice and clean. Okay, then rinse and dry off with a paper towel. We're gonna go ahead and rinse them off and dry them. Okay. Oh, I need a ruler. There we go. Okay. Okay, so sorry about the long wait. Okay, so next up is cut 3 aluminum foil rectangles. I definitely was not ready for this. Okay, so cut 3 aluminum foil rectangles, each 3 by 20. So we're gonna do 3 by 20 centimeters. And we're gonna just do 2 more of the same type. Okay. Cut those. Okay. All right, so we got 3 like this. Okay, so we got 3 right there. Okay. So we're gonna use oranges instead of lemons. So roll the orange. Oh, fold each strip in thirds lengthwise to make 3 sturdy 1 by 20 centimeter aluminum strips. Okay. So we'll make these into thirds. Okay. Okay, so we got 3 of these. Next up is roll the lemon gently on a table to break the cell walls and loosen up the juice inside. Just make a small cut. So I'm gonna grab a knife and make a small cut in the middle of it, about 2 centimeters long. So we're gonna kind of measure it. Okay, so 2 centimeters long, 1 centimeter deep, so about that much. Okay. So, okay, we'll do it like around here. Okay, so make a small cut near the middle of the lemon, about 2 centimeters long, and 1 centimeter deep. Make a second similar cut about 1 centimeter away. So 1 centimeter away is like around there. Okay. Alright, so push a penny in the first cut. So where are my pennies? Okay, they're in this paper towel. Okay, so push the first penny in the first cut until part of the penny is in contact with the lemon juice. Okay. Slide one of the aluminum strips in the slide one of the aluminum strips in the second cut till you're sure part of the lemon is in contact with the lemon juice. Okay. I'm gonna make it a little bit wider because it's hard to get the aluminum in there. Okay, so that's in. Push a penny. Okay. Attach the second aluminum strip to the part of the penny sticking out of the lemon with a plastic coated paper clip. Oh, okay. So then bring a second aluminum strip to the penny with a plastic coated. Okay, so we'll attach this. Okay, got it. Okay, now what we need to do is bring the two aluminum strips into contact. As soon as the two aluminum strips touch one another, electricity will be produced in the battery and flow through the strips from one electrode to the other. You cannot see the electricity flowing. You can try to feel it. Keep the two strings about 1 centimeter apart. Okay. Yeah, so I can notice that they're magnetizing to each other. So there definitely is something going on, and they're moving about. Oh man, that was crazy. Right, interesting. So there's a battery, the first one. Then, okay, I'll keep that in there so we can compare each other. And then we're gonna make a second one with this one, just to make sure that we're doing it, that it's constant. So about 1 centimeter deep. We're gonna go 2 inches or just one, like 1 centimeter away from each other. And we're gonna do the same thing. So we just need to cut out one more of these. Okay, so then we'll fold these. Okay, so we'll put a penny in the first one. Okay, then we'll put aluminum in the second one. Okay, and then we'll connect, and then we'll get the other one and connect that with a paper clip. Oops. Okay, and then we'll connect these and see if they're similar. So this one isn't working as well. Might be because of something I did on this. I cut out another spot right here, so there might be like a release of energy through this hole right here to where it's not doing charge between these two as well. You can definitely see though that seems like they're tingling a little bit around each other. So we're gonna go through the questions now. So which material is the positive and negative electrodes of your battery? I'm assuming that the negative is the penny, since copper is large, or is usually negative. I looked that up. And then the foil is a positive, and so by having the positive and negative, they're able to interact with each other. If you have a voltmeter, measure the voltage and current of your so I don't have that. How many lemons would it take to equal a car battery? So with this, I was gonna take out the spiral energy, and 1 gallon of gas is 10 to the 8th. So if it's 10 to the 8th joules, is one gallon, and you need about 20. I mean, like, you pretty much just need a gallon of, you just need that. So let's say that that's about 10 to the 8 joules is how much you need to run a car battery. And since we know that lemons, or like usually fruits, can give about 40 they can give about 40 megajoules for each kilogram. That's around there. And since this is maybe a kilogram, so maybe a little bit less than a kilogram, but you know, it's, so we could probably half it. It's maybe like a half a kilogram, which means that this is 20 milligrams, or megajoules, I mean. And then 20 megajoules is 20 times 1 to the e to the 6th, which is just 1 million, I believe. So it's really 2e to the 7th joules per kilogram. And since this is about, or per half kilogram, I should say. So that means that for this one, it will do 2e to the 7th joules for 1 half kilogram. And then kilogram is about 1 gallon of water is about 4 kilograms. So since 2e to the 7th is about 1 to the, or 10 to the 8th. Wait, why did I do 10 to the 8th? Oh, because it's that. So that's 1 to the 9th actually then, right? So if that's 1 to the 9th, then you're gonna need about 1, 2, 3, 4, 5, 6, 7, 8. You're gonna need about 8.5 lemons in order to power a car. So 8.5 lemons to power a car. And that's it. You know, I would just mention that I only used oranges, but one of them was kind of off. But you do definitely get energy coming off because of the positive and negatives. So, thank you.